All right, so we're going to do one more example with respect to x and y so you can see which way maybe is easier depending on which way you look at it. So I want you to graph both of those functions. They both are, in fact, functions. So go ahead and graph them. You have to solve for y to do it if you're going to use your calculator to help you, and find points of intersection. And when I come back, I'm going to have the answers on. So pause right now and do that. All right, so I have these two functions graphed. The y to the third equals x is the red, and the blue is the line, obviously. So I'll kind of color code over here. Now, I actually just cube rooted it to get it solved for y, and because it's a cube root, we don't have to worry about plus or minus. So this one turned out to be a function. And this other one is already solved for y, and it's solved for x, so that's handy. So if I'm going to take the integral with respect to y, find the area between the two curves, there's actually two parts. They're actually the same, so you could actually find one and multiply by 2, but we're going to remember how to split this into two pieces. So if I'm going with respect to x, I do -1 to 1, because I start at -1 and I end at 1. And I have to do my top curve, which, I have to go to 0 because my top curve switches, which I just got done saying and didn't take into account. Okay, so on the first part, my top curve is the line, the blue curve, so x. And then my bottom curve is the cube root function, so that guy, dx, like I said before, these are the same, so you could just multiply this by 2. These two regions have the same area. It certainly looks like they're symmetrical. So you could multiply by 2, but just to think about setting it up for the second part, 0 to 1. Now, the top and the bottom, reverse. So the cube root of x minus the bottom, which is x, dx. Now, this is, again, one you should be able to do by hand. I'll let you go ahead and do that. Stop the video, calculate, and get your answer. Okay, at least this was what I got for my antiderivative. Pause again if you need to go back and check your work. These are the values I got when I put in my limits of integration. Pause again if you need to double check those. And so I showed my work, but that's my final answer is a half. All right. So let's try this with respect to y. Now, remember, we're going to do right minus left. I believe in the last video I might have said it backwards. And I might have even written it down in the formula box wrong, so go back and fix that if I did. It should be right minus left, because right is the bigger number, left is the smaller number, okay? So that's the way it would go. I kind of visualize this by turning the axes on its side 90 degrees. And I rotate it counterclockwise when I do that. But then the positive values are to the left and the negative values are to the right, so you have to be careful with that. So when we set up this integration with respect to y, we're still going -1 to 1, but we have a stopping point of 0 in there, so -1 to 0. And then on this portion right here, okay, this bottom portion from -1 to 0, we have our right-hand curve being the cubic. But remember, we have to solve it, and I'm still doing it with respect to x because my brain likes to work that way, as I'm assuming yours does too. We have y cubed, rather, I tried to do cube root, the cubic, y cubed minus y. Okay, so this curve is x equals y cubed. So we are going to use what x equals, just like we use what y equals when we do the other way. Okay, and from 0 to 1, now we have the line being first and the cubic being second. dy, I can't fit it in, so I'll squeeze it. Right, and I think this is so much simpler to integrate, as I'm already doing it here, and you should be too. Now, I feel so much more comfortable doing this integral. Now, I had a harder time setting it up, and I'm assuming you do too. But it's a trade-off that you decide to do. So, you have to decide which is worse. Dealing with all the cubics, the cube roots, and dealing with maybe use substitution that comes along with it, like in the last problem, or You make your problem a little more simple to do the arithmetic, but maybe a little harder conceptually to set up. All right, so you go ahead, pause if you haven't checked right now, and go ahead and calculate this. If you don't get a half, you probably did something wrong somewhere. So go ahead and check that, and that should be your answer.